Alright, we're going to start today's lesson by doing a warm-up, a find the fiction. So you are given 3 different scenarios, and 2 out of the 3 can be modeled best by an equation that is in standard form. So think back to what we were talking about. When we say a standard form, it's that something times x, we can call it ax, plus something times y, or by, is equal to c, some constant. So read through these 3 scenarios right now and decide which 2 out of the 3 are best modeled by an equation in standard form and which one is not best modeled by an equation in standard form. Pause the video and take a few minutes to do the warm-up right now. Go. Now that you've attempted the warm-up on your own, I want to talk through my thought process as I'm thinking through these different scenarios. So the first one says, Reggie gives students homework assignments that are worth 20 points and tests that are worth 60 points. So I'm just going to kind of highlight as I go. So homework assignments are 20 points. I know tests are worth 60 points. And then I see that I have this total, and I'm going to box in a total. I'm thinking through, okay, if I have a total of 300 points, totals are often an indication that I might be having an equation in standard form because you're adding 2 things together to equal a total. So the equation in this case would be 20 points for each homework assignment. So I'm going to say 20H plus 60 points for every test. That'd be 60 times the number of tests, and if I add those together, that'll give me the total number of points in a class. So again, when I can see things that I'm adding 2 things together, I kind of have 2 different rates. I'm going to add them together and equal a total. That would be standard form. So this one is not, this one is best modeled in standard form. This next one. So Janet, we should say, spent $300 when she went to the market. All right, so that's the total amount she spent. She bought 5 pounds of soup and 3 pounds of meat. Now, we don't know how much she spent on soup or meat, but we have that she bought that much of those things. So here, you're still buying 2 things. We don't know the cost of each of them, but when we add them together, we should have 300. So again, this is going to be 5 pounds of soup times, in this case, it'll be the cost of the soup, plus 3 pounds of meat times the cost of the meat will equal her total of 300. So this one is actually written in standard form as well. Over here, we see Kara deposited $65 every month. Okay, so we got this rate of $65 every month. That's a rate. And $300 in her she had $300 in her account after 3 months. So this is not a rate, it's giving me an input and an output. So if X is the number of months and Y is the amount of money in the account, what this is giving me is kind of like an ordered pair. An input of 3 has an output of 300. And then this $65 every month is my rate or my slope. So in this case, this would not be modeled by standard form best, or not best modeled by standard form. I would either start with point slope form or use a table to write it in slope intercept form. If I wrote this one in slope intercept form, I could either start in point slope form and then convert to slope intercept form, or I could make a table and say, well, at 3 months, I had $300. The next month, I would have increased that by 65, so I'd have $365. But the previous month, I'd have $65 less, so I'd have $235. The previous month before that, I'd have $65 less, so I would have $170. And then the previous month before that, I have $65 left, or $105. And I should get that same y-intercept regardless of which form I use, or which method rather I use. So now, just doing this, 65 times 3, that gives me minus 195. If I add 300 to both sides, y is equal to 65x. Negative 95 plus 300 is a positive 105. So my equation is actually best written in point slope form or slope intercept form, not in standard form. So C is the one that is not best modeled by standard form. All right, today I want to launch this new idea of vertical and horizontal lines by doing this launch. What I'd like you guys to do is take a look at numbers 1 and 2. I'll give you guys a few minutes to do those, and pause the video while you work. Go ahead and begin. All right, now that you guys have done this on your own for a little bit, let's take a look at this. Write down 3 things you know about the function y equals 2. So if I recall from earlier in the unit, y equals 2, you could also write that as y equals, I don't see an x, so the coefficient of x must be 0, okay? So I could say it has a slope of 0. Well, if it has a slope of 0, I remember a slope that's positive is increasing, a slope that's negative is decreasing, so a slope of 0 would be in between those positive and negative numbers. So I'm going to have a horizontal line. So the graph is a horizontal line. I also see this plus 2, and I'm reminded that that is translated up to from the parent function. So if the parent function has 0 as its y-intercept, plus 2 will add 2 points to, or 2 units to every point on that line, on the y-coordinate rather, and so this one will have a y-intercept of 2. There are other things that we can talk about that. You could just state the fact that it is linear. So there are other things you could say as well. You could also say that if you looked at a graph and you were talking about domain and range, if you look at this, this would be a graph in a different color. How's this? Red. You'd have a horizontal line at y equals 2. So if I'm thinking about domain and range, I could say the domain, well, those are my inputs, or my x values, which I know x goes left and right. So my lowest x value, well, if I go all the way to the left, that's negative infinity. My highest x value is positive infinity. My range, well, when I look at that, I don't really go up and down at all. The only y value, this is the point 0, 2. This is the point maybe 1, 2, 3, 2, 4, 2. I mean, I have an infinite number of points, but they will all have a y-coordinate of 2. So my range, I can just list as the number 2. That is the only value in the range, the only possible output for that function. All right, so then skipping down to number 2, it says create a table to model the vertical line shown in the graph. So here's my vertical line. If I'm making a table, I'm looking at this and I might see some points. So that's the point 8, 0, that's the x-intercept. We have the point 8, 2, 8, 4. There's points in the middle too, right? So 8, 3, 8, 1. I mean, there's decimals, so we could have 8, negative 0.5. But if I start listing these, 8, 4, 8, 3, 8, 2, 8, 1, 8, 0. When I look at this table for this vertical line, I can draw some conclusions. It says, what can you conclude about every solution to the relation? It says relation and not function because the input of 8 has multiple outputs. So it's not a function, it is only a relation. When it says solutions mean the points on the line. So what can I conclude about every solution? Well, when I look at that, I can see that the x-coordinate of every solution is 8. So the x-coordinate of every solution, and when I say solution, I just mean an ordered pair, right? X, y, or point on the line is 8. So now it says write an equation to summarize all of the solutions to the relation. So this one might be a little tricky, and I wouldn't be surprised if we weren't sure how to do it right away. But if we just think about what we mean by this previous answer, if every x-coordinate is 8, and it really doesn't matter what the y-coordinate is, the y-coordinate could be anything, how we communicate that in an equation is just that x is equal to 8. And you're not even going to see y in the equation because the ordered pair is not dependent upon y. X is 8, y can be anything. And we're going to use this idea now to start working with horizontal and vertical lines. So let's flip to the back. I want to summarize horizontal and vertical lines for us. If we think about horizontal lines, we know that the graph will look like that. Whereas vertical lines, the graph looks like this. If we think about points on a horizontal line, we might have the point, let's say that was 3, 2. The next point might be 4, 2. The next point might be 5, 2. So if you look at that as a table, 3, 2, 4, 2, 5, 2, we see the y-coordinate is not changing. It's remaining constant. But the x-coordinate does change. And in order to communicate this, we can think of this as a slope of 0. So the y-coordinate is not changing, but the x-coordinate is. So we have 0 over 1, or just 0. So my slope is 0. Whereas a vertical line, if I think about points here, this might be the point 6, 1. This could be 6, 2, 6, 3, 6, 4. If I were to look at that as a table, 6, 3, 6, 2, 6, 1, what I see is that my y values are changing, but my x coordinates, my x values, are not. And when my x values don't change, if I'm finding my slope, my change in y over change in x, this would actually be undefined. And if I put that undefined, if I put that in my calculator, the calculator would say error. So we have a vertical line has a slope that's undefined, horizontal line has a slope that's 0. These are already things that we know, but the big thing I want to talk about now is the equation. We've already talked about how horizontal lines have a slope of 0. So you might see y equals 0x plus something, but if it's 0 times x plus, let's say in this case, 2, I'm not going to write the 0x. I'm just going to write y equals 2 because 0 times x is 0 and 0 plus 2 is 2. So we're going to see an equation that looks like y equals a number. Whereas over here for vertical lines, to communicate that x is always 6, I'm going to have x equals 6. In other words, x equals a number. We don't really talk about this in slope-intercept form because the slope is undefined, so you can't write an equation in slope-intercept form. This is actually would be considered standard form where the coefficient of y is 0. All right, so now I want us to use this summary to practice some problems below. So for the partner work, what I want you guys to do is first start this on your own. So take a minute to try this on your own, and then when you and your partner have both tried it, check your answers. So for number 1, I want you to graph g of x equals 4, x equals -2, and let's do 3x minus 2y equals 12. Go ahead and try graphing these on your own right now and pause the video. All right, you should have already checked these with your partner, so I'm going to talk through how I did them. But hopefully after talking with your partner, you guys are feeling comfortable with this. So when I see g of x equals 4, that's just another way of saying y equals 4. I can think of this as y equals 0x plus 4 if I'd like. So I have a slope of 0 and a y-intercept of 4. I can also think of this as if I'm making a table, y is always 4. 4, 4, 4, 4. Y is not changing even when my x is. So if I were to plot those points, I end up getting this horizontal line. And so if I take my straight edge, I draw this horizontal line. There we go. Okay, looking at this one, it says x equals -2. Well, if I'm not really sure what that looks like, I can think of making a table here. If I have x and y, it means that x is always -2. And y can be anything, 1, 2, 4. Your values or your ordered pairs don't have a y coordinate that is dependent on the x coordinate. Y is not even in the equation, so no matter what y is, x will always be -2. And if I were to plot those points, and if I could continue, no matter where I go, if x is -2, I'm going to form this vertical line. So the correct graph here would be a vertical line at x equals -2. Over here, when I look at this equation, I'm saying, oh, that is not a vertical or horizontal line. This is actually in standard form, and with standard form we can graph this a couple different ways. One option would be to find the x and y intercept. So if I wanted to find the x-intercept, I substitute 0 in for y, and I would get 3 times x minus 2 times 0 equals 12. Well, negative 2 times 0 is 0, and 3x plus 0 is just 3x. So really what I'm seeing is that I would have an x-intercept at 4, 0. If I was finding my y-intercept, I know that the x-coordinate will be 0, so if I substitute 0 in for x, when I simplify, I'll get negative 2y equals 12, and when I solve for y, I get y equals negative 6. So I'll have a y-intercept of 0, 1, 2, 3, 4, 5, negative 6, and that will be my y-intercept. Now I could just graph the line here, and when I graph that, I'm good to go. What I can also do is take this equation and write it in slope-intercept form. So if I were doing that, I'll do that to the side, maybe in a different color. We'll try that in orange. If I had 3x minus 2y equals 12, and I can zoom in so you guys can see this a little better. If I'm solving, or if I want to write this in slope-intercept form, I'm essentially solving for y. I can subtract 3x from both sides. I get negative 2y equals a negative 3x plus 12. I can divide by negative 2, and when I divide by negative 2, I have to divide everything on the right-hand side by negative 2. So negative 3 divided by negative 2 will be a positive 3/2. Then I have my x. A positive 12 over negative 2 will be a minus 6. So in slope-intercept form, I should have a y-intercept of negative 6 and a slope of 3/2. So I have a y-intercept of 1, 2, 3, 4, 5, 6. Yep, that's where I got it. A slope of 3/2. Rise 3, run 2, rise 3. Oh, it looks like I plotted this wrong. Oh, I did. I said my x-intercept was 4, 0, but I plotted it at 5. Well, it's a good thing I checked. Here we go. Let's draw that line a little bit better. This is what my line should be. All right, I said 4, 0, but I plotted 5, 0. There we go, much better. All right, so there's 2 ways you could go about doing that. All right, what I want you guys to do next is, on your own, try number 2. You're writing the equation of the line. Take a minute to try this on your own. Once you and your partner have both attempted the problem on your own, check your answers with one another. Go ahead and begin and pause the video. All right, now that you've attempted them on your own first, and then you checked your answers with your partner, I'm now going to discuss my thought process. One, when I look at this, I'm thinking, okay, I have a horizontal line. My slope is 0. I'm not rising anything, so my slope is rising nothing, but running something, or a slope of 0. That tells me I have a horizontal line. My y-intercept is 0, 2. So I can think of this as y equals 0 times x plus 2, or just y equals 2. If we weren't sure how to do it that way, another way to do it is kind of look at the points and make a table. And we can see we have x and y. We have 0, 2, 1, 2, 3, 2, 2, 3, 2. And what I can see is that y is always 2. The y is not changing, even though x is. And so there's my slope of 0 and my y-intercept of 2. Or just looking at this and saying, well, if y is always 2, the equation to represent that would be y equals 2. Switching over here, I have a vertical line, and what I notice about vertical lines is that every x-coordinate remains the same. So if I were to make a table of this, I have 3, 0. This would be the point 3, 1. This would be the point 3, 2, or 3, 3, and it would continue on, but no matter what point I listed in the table, I see that the x-coordinate is always 3. So to communicate that, I say x equals 3. If you think about this trying to find slope, your y's are changing by increasing by 1 based on the numbers I chose. So my slope would be change in y over change in x, but this is undefined. So I'm kind of stuck. I can't really write this in slope-intercept form. I have to think of a different way to write it. And then finally, looking at this line, when I look at this line, I see that we are decreasing, which tells me that I have a slope that's negative. Specifically, if I have a point here, and where's my next point? There we go. That was the one I can find for sure. So I go down 3 and right 4. So my slope, you can say rise 3, run 4, but remember we're decreasing, so that should be a negative 3/4. And then I have a y-intercept of 0, 4. So I can write this in slope-intercept form because I can find the slope and the y-intercept. So I'll have y equals my slope times x plus the y-coordinate of my y-intercept. And there's my equation. All right, so for the final problem, I still want you to write an equation. So when I write an equation, you're going to see an equal sign, but it satisfies the given information. So this is going to be giving you a little bit different information. You're going to have to think up a little bit about it. Again, start these on your own first. Once you and your partner have both attempted them, then check your answers with your partner. And once we've done that, then play the video and see my explanation for number 3. Go ahead and pause the video now and work. All right, now that you've tried these on your own, I'm going to talk through my thought process as I try these problems. So I'm writing an equation of a line that is only in quadrants 2 and 3. Let's have a little refresher if you didn't remember. When we name quadrants, we start here in the first quadrant, and then we go counterclockwise. So that's quadrant 3, quadrant 4. So what this is looking like, if I'm sketching a graph, to only be in quadrants 2 and 3, that means I have to be in these quadrants, which forces the line to be a vertical line. Because if it wasn't a vertical line, then at some point it would tilt over and get into the other quadrants. So it would either run into quadrant 1 or 4. So the only way for this to be only in quadrants 2 and 3 is if we have a vertical line. So I'm thinking, okay, a vertical line, that means every point on this line will have the same x-coordinate, because I'm not going left or right at all. It's the same x-coordinate. It doesn't tell me specifically what that needs to be, but I do know that if it's in quadrants 2 and 3, we got to be to the left, which means the x-coordinate has to be negative. So one option would be x equals negative 2. It doesn't have to be that, though. It's just anything that is negative. Negative 1.5, x equals negative 100. But we need to have a vertical line, which will be if the x-coordinate's not changing. So x has to stay the same. So it would be x equals and then some number that is negative. All right, for B, it says a line with a slope of 0 that has a range of negative 3. Let's think about what that means. A slope of 0, well, I remember that a slope of 0 means I have a horizontal line. So I'm thinking about what this looks like. I'm going to have a horizontal line. It says the range is negative 3. I remember ranges are my y values. So the only y value I could have is negative 3. So if I was thinking about this as a table, essentially if I have negative 2, negative 1, 0, 1, 2, no matter what the input is, the output must be negative 3. Well, what this graph looks like then is a horizontal line that has a y-intercept of negative 3. Well, essentially every point on that line has a y-coordinate of 3. So my equation in this case would be y equals negative 3. There's no other possibility besides that. That would be the only line that has a slope of 0 and a range of negative 3. Switching to the very last one, it says a line that has the same steepness as y equals 3x plus 4, but is translated down 6 units. So let's think about that. The steepness is determined by the slope. So when I look at this equation, remember the coefficient of x is what impacts my steepness. So if that has to stay the same, I know I'm going to have y equals 3x, because that's got to stay the same, but I have to translate down 6 units. Well, this original function, if I graph that, has a y-intercept of 4. It was already translated up 4 from the parent function, but I want to go down 6 from here. So if I translate this entire function down 6 units, 1, 2, 3, 4, 5, 6, and each one of these points would also be translated down 6. I'm going to have a line that looks like that. So essentially the steepness didn't change, so my slope is still 3. But now once I translate down 6, I'm essentially subtracting 6 from the function, or I'll land with a y-intercept of negative 2. So I'll have, oh, I didn't need that, y equals 3x minus 2. And again, this is one that would only have one possible answer to meet that criteria. All right, we are all set for today.